So here's another one where it's asking for the radius of convergence. So basically it's saying what are the possible x values that will allow this function to converge. So we could use the ratio test, not ration, ratio test. So take the limit as n goes to infinity, substitute n plus 1, and the x, you just pretend that it's a constant for right now. So substitute n plus 1 for all of those n's, and then divide by the original function, and as I'm sure you know, that means invert and multiply. So the 2 to the n goes to the top, the n and the 2x minus 5 to the n goes on the bottom. And because x could be positive or negative, we then put it in absolute value. And next up, get a blue pen in order to cancel. So this 2 to the n will cancel this 2 to the n, leaving a 2 on the bottom. This 2x minus 5 to the n will cancel this 2x minus 5 to the n, leaving a 2x minus 5 to the 1. And as far as canceling, that's about it. So put away my blue cancel pencil. And what's left? So on the top, we have an n plus 1 that did not get canceled. We have a 2x minus 5 to the 1 that did not get canceled. All right, that's the numerator. And the only thing left on for the denominator is that single 2, and then also this n. And then basically we have the n going to infinity and 2n going to infinity, so we could use L'Hopital's rule. It's like deja vu all over again. Seems like L'Hopital's rule keeps showing up. All right, so the derivative on the top, so the n is the variable, so we're taking the derivative of the n part, and the derivative on the top will be 1, the derivative on the bottom will be 2. And then the 2x minus 5 stays there, and the ratio test says this will converge if, in absolute value, it's less than 1. So in order to eliminate the absolute value, I could just say this 2x minus 5 over 2 can be sandwiched between a negative 1 and a positive 1. And then just do the algebra to solve for x. So multiply all three sides by 2. And then add 5. So add 5. Don't want to mess up my arithmetic. So 5 minus 2 is 3. And then this would be 2x. And this would be 7. And then divide by 2. So this will be 3 halves, or a 1.5. And then this will be 7 halves. So basically, if you look at a number line, this would be the 3 halves, or 1.5. This would be the 7 halves, or 3.5. And for all of the x's in between there, the series will converge. And then what's the radius of convergence? So if you look at what's in the middle, and then you go this way, that would be what the radius equals. Or if you go this way, an even amount, that's what the radius will equal. So what's in the middle? Well, since this is a 3 and this is a 7, what would be in the middle is 5 over 2. And then to go from 5 over 2 to 7 over 2, so 7 over 2 minus 5 over 2 equals 2 over 2. So the radius is 1. So that means that this series is centered at x equals 5 over 2, that was the middle number, with a radius equal to 1. And we're done with that one, but if you stick around for just a few more seconds, let me explain what's happening. So if you were to look at the x-axis from 3 over 2 to 7 over 2, then the function over here would go to infinity. It might go up to positive infinity or negative infinity, I'm not sure, but it's going to go to one of the infinities. And the other side would also go to infinity. But as the function reaches this area, then it would behave very nicely and it would give you finite answers. And then by the time you get to 7/2, it then goes off to infinity. Okay, that's it.